This is the first lesson from the Chemical Bonds and Writing Chemical Formulas unit. In this lesson, you will learn about the different ways that elements can make chemical bonds and some of the new properties that they have after they create these bonds. You should have your note sheet in front of you right now, and you should be ready for any hidden talking points that might come up throughout this lesson. First thing that we need to talk about is why elements create chemical bonds. And the reason is because there's stability in bonding. Now, not all elements are uncombined in nature. Sometimes, under certain conditions, elements can react with others to form compounds. For example, copper, sulfur, and oxygen react to form copper sulfate. Copper sulfate isn't shiny like copper, a pale yellow solid like sulfur, or an odorless gas like oxygen. It has its own unique properties. And over here on the right we can see this is sulfur, so you can see what that looks like. It's just yellow. This is copper, and it's a penny. And this is copper sulfate, the Statue of Liberty here. Now, the Statue of Liberty is green because it's originally copper. Now it's combined with sulfur and oxygen. That's where it gets its green color. So for your first talking point on the left-hand side, I'd like you just to write Statue of Liberty. Moving on to letter I. When elements react, they have properties different from either element that has combined. For example, this is pure sodium. It could burn a hole through your skin. And this is pure chlorine, which would kill you if inhaled. But when they are combined, they make table salt, which is something that we eat in our foods and our body needs to function every single day. Letter B discusses chemical formulas. What a chemical formula does is it tells what elements are in a compound and how many. So you can pause, or I'll wait a second for you to write that down. One of the compounds that you are most familiar with is H2O. You don't need to write that down. But one H2O has two hydrogens and one oxygen. That's what this is showing right here. Is these are two hydrogens and then just one oxygen here. This 2 is called a subscript. And a subscript tells how many atoms of an element are in a compound. Now, for your second talking point, what I need you to do is I need you to choose two chemical formulas from the list, write the chemical name and the formula. And I just want to point out that all of these, what this means is that this would have 2 carbons, 5 hydrogens, an oxygen, and a hydrogen. This one would have 2 hydrogens, a sulfur, and 4 oxygens. So that's what a chemical formula tells us. So you need to pick 2. Please write them in the blank right underneath chemical formulas on your sheet. And now we are moving on to atomic stability. Atoms form compounds when the compound is more stable than the separate atoms. Noble gases do not form compounds because the compounds are less stable than the original. So if we look at the bottom down here, we see this is a picture of sodium and chlorine. Sodium is unstable by itself, chlorine is unstable by itself. When they combine together, they are stable, and that formed table salt that we talked about earlier. Now, to understand stability, we need to look at electron dot diagrams. Okay, so the groups of the periodic table tell us how many dots we need to make. So we need to write the electrons for each group listed here right now. So group 1 has 1 outer electron, group 2 has 2 outer electrons, group 3 has 13, has 3 outer electrons, group 14 has 4 outer electrons, group 15 has 5, group 16 has 6, group 17 has 7, and group 18 has 8. So, elements are chemically stable when they have full outer energy levels. Noble gases already have complete energy levels. That's group 18. All other groups fall short of full outer levels. And these atoms must react to obtain full outer energy levels. And they can do this by losing, gaining, like sodium and chlorine here, or by sharing electrons. Now we're going to talk about what happens when elements are reaching stability. In this case, sodium and chlorine react to form sodium chloride. Sodium loses 1 electron, and chlorine gains this 1 electron. When sodium gives an electron away, the energy level underneath has 8 outer electrons. You can see these 8 outer electrons right here. Now sodium has a positive charge, chlorine has a negative charge, and they stick together. This is different than in a compound like water. In a compound like water, hydrogen and oxygen share electrons. This causes an attraction between the atoms. This attractive force is called a chemical bond. Now we're going to move on to the types of bonding. The first type of bonding that we're going to talk about is ionic bonding. Atoms can gain or lose electrons. When this happens, an ion is formed. So how this happens is sodium will lose its electron. So this electron is going to move from sodium and it's going to be attached to chlorine now. Now this is a positive ion and chlorine is a negative ion. And basically what an ion is ions are charged particles that have more or fewer electrons than protons. The atom that loses electrons is positively charged. The atom that gains electrons is negatively charged. This electrical attraction creates what is called an ionic bond. An ionic bond is always between a metal and a nonmetal. Metals have positive charges and nonmetals have negative charges. Now we're going to discuss covalent bonding. Some atoms become stable by sharing electrons instead of losing or gaining. You can see here that hydrogen here and water are sharing these electrons and sharing these electrons. You can see it here too. When atoms share electrons, it is called a covalent bond. The name for two elements that are covalently bonded is a molecule. Covalent bonding can make single bonds or it can make multiple bonds. And what a single covalent bond is, it's when two atoms share one electron to make a bond. So in this case, oxygen has a full outer 8 and hydrogen is full with 2 from the sharing. So if you see, they're sharing these 2 electrons here and these 2 electrons here, and they're both sharing 1 electron, and that makes a single bond. Atoms can also make what are called multiple bonds. Multiple bonds mean that atoms can share more than 1 electron with another atom. An example is shown here is N2. In this example, 1 nitrogen is sharing 3 electrons with the other. This is called a triple bond. And this is the triple bond right here. If an element is sharing 2 electrons, it is called a double bond. This is always between 2 or more non-metals. this picture is showing an unequal sharing of electrons. So sometimes the sharing of electrons is unequal. When sharing is unequal, one of the atoms pulls harder on the electrons than the other. In this case, if you look, the oxygen right here is pulling harder on the electrons than the hydrogen is. That's why these little dots are all closer to the oxygen. The atom that pulls harder has a partial negative charge, and the other has a partial positive charge. So that's why I wrote positive by the hydrogens and negative by the oxygen. That is the end of lesson 1 on chemical bonding, and after this you can work on your concept map.